Hi, my name is Noah Arnold, and this is my Lab 3 for Physics 2212 at Georgia Tech, the magnetic field of a bar magnet. Today, I will be going through an introduction, going over the physical principles used in this lab, as well as the purpose, and a brief look at the results of the lab. We'll go through the computational model, we'll go through expectations versus observations, and then finally I will be answering the discussion questions for this lab. Purpose and results. The objective of this lab was to measure the distance dependence between the magnetic fields due to the bar magnet. We are then to compare the theoretical results due to the computational model results. A preview of my results. The magnetic field dipole moment ended up being 3.41, and then the proportional to distant exponent was negative 2.9. In this lab, we use a few different basic physics concepts needed to understand what is going on. We need to understand how bar magnets work and the physics behind them. We need to understand the dipole magnetic field, the Biot-Savart law. We also need to bring in superposition and think about magnetic field superposition. We also need to understand linearization and what it does to a model. In order to do this lab, we had to download the Magnetometer app. After doing that, we found the magnetic north, set a meter stick perpendicular to this magnetic north, and then after using the phone and putting it in a few different positions, we were able to find some measurements that we then recorded into a provided spreadsheet. These procedures can be seen in the diagrams provided here. In order to estimate R, we need to plot the natural log of b of x against the natural log of r. This transforms or linearizes the equation. And then after some calculations, I found that n was approximately negative 2.9. Next, I needed to create my code. First, I inputted the magnetic field function and performed the calculation. From this calculation, I got a calculated value of 1 times 10 to the negative fifth, comma, 3 times 10 to the negative fifth, comma, 0t. And then from that, you can move on, initialize the vectors, and then find the relative position vectors, and then eventually this will lead you to the output that you can see to the left here. If you look at all of this, you can see the results. Finally, to answer the question of what would have happened if we hadn't have played the meter stick at some angle that wasn't parallel with Earth's magnetic axis, I would say that if it weren't at that parallel, then Earth's magnetic field would have interfered with our experiments, which would have made all of our measurements inaccurate. So it was very important that we place the meter stick exactly at that position. And then if we were to redo this experiment, instead of using a single magnet and instead use two identical magnets, how would everything change? Due to the fact that the second magnet would make the magnetic dipole moment stronger, it would then make the magnetic field stronger, so it should increase our measurements.